While this is a calculator problem, we can easily graph these two things and find the region that we're revolving. All right, let's take a look at part A. If you do vertical representative rectangles, you're going to have to do two separate integrals because from x equals 0 to x equals the red line, we've got blue boundaries. And then from the red line and beyond, we have blue boundaries to a green boundary. So we can do vertical rectangles with two integrals and get the area this way. Since our representative rectangle has a dx, everything needs to be in terms of x's. We're doing the y values, the upper y value minus the lower y value, so upper blue curve, lower blue curve, and those y values are positive and negative square root of x. So the upper one minus the lower one gives us the vertical distance. Dx gives you the height or width of each rectangle, and we need to go from 0 to whatever this x value is right here, which is, using our calculator and entering y1 equals x squared minus 1 and y2 equals negative square root of x for the bottom part, we can do the second calculate intersection and find that that intersection point is here, and we should store this value using our calculator's store button, which is right to the left of the 4 and to the left of the 1. To the left of the 1. We'll store that in A, we'll store this in B, and then let's also go ahead and find this intersection point while we're at it. And when you find the intersection of this function and y equals the positive square root of x, we get this x value and this y value. I'm going to store that in C and that in D. All right, so to complete the area of the region the long way with two different integrals, we'll go from x equals 0 to x equals a. And that would give the region to the left of the red line. And then for the region right of the red line, we're doing the blue minus the green for our length of the curve, width of the curve dx, from the x value of a to the x value of c, which is approximately 1.377. Now let's do it the easier way. Use horizontal representative rectangle, so the differential is dy, and we'll do a single integral from y equals b to y equals d. Then for the length of a rectangle, we need the biggest x value minus the small x value. So the green x value minus the blue x value. The green x value is y plus 1 square rooted, and the blue x value is y squared. That's it. And we get the same answer with much less work. All right, for part B, we're going to use the same region. Still have those values from the intersections in part A stored in AB for this point in CD here. That'll come in handy, less writing. And let's see, we're revolving this region around the vertical line x equals 2. This x value right here, C, is only about 1.49, so 2 is going to be to the right. All right, so this pink region gets revolved around this axis of revolution, the vertical line x equals 2. So we're going to do big disk minus the inside disk, or in other words, the washer method. Consider a representative rectangle, and this will be the center of our disk, with the blue edge being the big radius. So from the red axis to the blue line is the big radius, capital R, and that's kind of what the disk looks like. Its volume is the area of this circular base multiplied by its height, which is dy in this case. So the volume of that big disk is the distance from the red line to the blue line, which is the x value of 2 minus the x value of y squared. So there's the big radius, so pi radius squared times the height is the volume of the disk, and we'll do that for the entire region. Remember, these are dy's, so as y goes from B to D. Then from that disk, we don't want all the white region, so we're going to be subtracting the inside disk, whose radius is the distance from the red line to the green curve. And the red line is again 2, and we subtract the x value of the green curve to get that inside radius from here to here. And the x value of the green curve is the x value of the green curve. So we take the green curve, solve for x. That's the positive root of y plus 1. So there's our pi radius squared times height is the volume of that inside disk that we're subtracting, which leaves us just with the washer, or the volume cut up by this red regional represented rectangle as it rotates around x equals 2. All right, that's it. We could simplify if we wanted to. We don't have to, but we could. That would just look like this. Nope, thought better of it. There's no reason to. This is a calculator problem. Let's put it in our calculator and see what we get. Wait a second, I forgot the limits of integration for that second one. Oh, it's the exact same thing, from B to D. And you can see how it's not that hard to enter when you've got those nice values stored in B and D. You get 11.501. That's how you do 12B. 12C, there's a video already at the YouTube playlist, its own video for 12C.